I was about to say good evening. Good morning, guys. Hope you guys are all doing well. Hope you are having a good half-term break. I can see a lot of familiar names from the group classes, so I hope you're all doing well. I'm just going to give a few minutes, or a few seconds, just so more people can join. But I hope you guys are all doing well. Hope you're having a good half-term and studying hard for your exams next week. So I've got a couple people in the waiting room. Okay, cool. So we'll make a start. So just as an introduction for anybody that's new today, I can see a lot of familiar names, some unfamiliar, but just as an intro, my name is Daniel. I'm a GCSE and A-level maths tutor, and I run online classes week by week. So what we're going to do today is we're going to go over a couple of random past paper questions. What I'll do is I'll give you a chance to have a go at it on your own, and then we'll go through it together. Just see the chat. Remove. No worries, no worries at all. No worries at all. No worries at all. Okay, so what we're gonna do, I'm gonna share my screen, and yeah, you guys should be able to see my screen in a moment. Oh, let me just do it one more time. Hold on. Okay, yeah. So that's me. I run Maths with Dan, my tutoring company, and you can catch me at all of these socials. So I'm on TikTok, YouTube, and Instagram, and so on and so forth. So what we're going to do is we're going to make a start. So let me go to the questions for today. So we've got a couple of questions. So just as a point for anybody that's new today, I've just got a couple of people joining. Okay, yeah. So I'm just going to wait for a few seconds for the people that are in the waiting room to join and connect, and then I'll just explain again, just very briefly, how the classes are run. I know majority of you know how they run anyway. Let me just see. Okay. Cool, cool. Good morning to anybody that just joined a few moments ago. So we're just about to start the questions. So the way the questions are run is I'll give you a chance to have a go at it. Depending on how many marks, depends on how many minutes I'll give you. So for example, the first one is 1 mark. So I'll give you a minute to try it. And yeah, have a go at it, see how you get on, and then we'll go through it together. Yeah. So the first one is a 1 marker. It says circle the expression that means half the value of X. What I want you guys to do is have a go at this. Hello, I cannot hear anything. Hold on. Can you guys hear me, by the way? Can somebody let me know in the chat? Okay, okay. Let me just message that person. Hi, hold on. A lot of people are joining. Just 1 second. Let me just sort this out for anybody that can't hear anything. Still can't hear anything? Let me just see. Okay, okay. Let me just message her. Hi. So you guys haven't got any questions. See how you get on. We'll go through it together. I'm just gonna message that person. Okay. Okay. So looking at this one, guys, how are we feeling? Put a one, or no, put a zero if this is very confusing. I have no clue what to do, and put a 10 if this question is super, super easy. What do we think? Can see a five, cool stuff, cool stuff. Any other numbers, guys? Can see a 10, good stuff, Josh and Matthew. Six, good stuff, Carter. Okay, so I'll give you a few seconds more, and what I want you guys to do is to put your answer in the chat. Remember though, before you put your answer in the chat, if you want, you can put a message to everyone so everybody can see your answer. But remember, you can message me directly. So if you have an answer you don't want everybody to see, then you can just put a message to me directly so I can see what your answer is. Yeah? Hope that's all clear. Let me just make sure. Okay, let me see. Ivano's joined again. She still hasn't connected to sound, so I don't think she can still hear me. Maybe she needs to join from a different device. Let me just see. Okay, okay. Okay, cool. So what I want you guys to do is I want you guys to all give me your answer in the chat, please. What do we think the answer is? Is it x divided by 2? Is it 2 divided by x? Is it a half minus x? Is it x minus a half? What do we all think the answer is? I want you guys to all put your answer in the chat for me, please. Right. Good stuff. Good stuff. Well done, Zariah, Matthew, Elia, Gideon. It's x divided by 2. Yeah. Now let's just go through it very, very briefly. Thank you very much, Josh and Jeremy. So circle the expression that is half the value of x. Let me just get my pen. Yeah. So this one here, what you could do is you could say to yourself, okay, well, half the value of x, you could use actual numbers to answer the question. Remember, we're dealing with algebra here. What do we like to do when we're dealing with algebra? Let's use numbers that we're familiar with to help us understand the question better if it's a bit confusing. Well, half the value of x, let's say, for example, let's say x was equal to 10. Well, half of that would be 5. Why? Because 5 is the same as 10 divided by 2. Let's do another one. X is equal to 100, right? Half of that is 50, right? Why? Because it's 100 divided by 2. So you can just use actual values, actual numbers to help you get an idea of what the question is asking and then extend it to letters. So now we know that it's the number divided by 2. It must be x over 2. Does that make sense, guys? Well done, Joel. Fantastic. Yep. For anybody that maybe did not get this correct, is this clear now? Anybody have any questions just before we move on to the next question? I want to make sure we're all okay with that. And Ivano still can't connect. Guys, you guys can still hear me clearly, right? Because I don't think Ivano still can't connect. Shay, that's it, Shay. Sorry, Shay. Cool. Okay. I think maybe, I'm not sure why. Okay. Well, what we'll do, I'll drop her another message or him, and then we'll go to the next question anyway. Yeah, so this is the first one. We're going to go on to the next one now. Now, this was 2 marks. I forgot to put the mark there, but this is 2 marks or 3. So I'll give you about 2/3 minutes to try it and see how we get on. What I'll do in the meantime is I will try and help out that student that cannot hear. Okay, I think she's left and come back. Okay. So finding the LCM, how do we find this as a topic, guys? This type of question, we know it always comes up in an exam. Put a 0 if you don't know how to do this, very, very confused, and put a 10 if these questions are super, super easy. I can't wait to see this question when it comes up. I can see 9s, I can see 10s, good stuff. I'll give you a couple minutes more. We'll go through it together. Good stuff. I can see 9s, I can see 10s, I can see 7s. Great stuff. Give you guys about a minute more. We'll go through it together. Well, so for those of us, we're doing question 8. So we're going to do question 27A after, yeah? But we're doing question 8 for now, because somebody's given me an answer to the standard form question, so sorry about that. But we're doing question 8, yeah? And I've got a couple of answers, so we'll go through it very, very shortly. Okay, cool. So I think it's been about 2/3 minutes. Let's go through this together. All right, so putting this here. Let's see what it says. So it says, find the lowest common multiple of 70 and 56. All right, so whenever you do these questions are easy. You've got to do 2 things. First thing is that you've got to draw factor trees for both of your numbers. So we've got 2 numbers, 70. We've got another number, 56. Now, these are both even numbers, so I'm just going to break them down as much as I can. So, for example, I'm going to write, well, this is 2 and this is 35, right? And then now, well, what do I have here? What are the factors of 35? Well, there are 5, right? And a 7, yeah? Now, all of these numbers are prime numbers, so we know that we can stop here. These branches here at the end, these numbers at the end of our branches are the numbers we multiply together to give us our answer, yeah? So therefore, we can say 70 is equal to 2 times 5 times 7. Now I've got my factor tree for 70. I'm going to do the exact same thing for 56. Yeah. So put this here, put this here. 56 is again is an even number, so I'm going to put a 2 here. What is half of 56? Well, this is just half of 50 is 25, half of 63, 25 plus 3 is 28. This is 28. Yeah. And then now, again, this is another even number. This is 2 and this is a 14. And then one more. This is 2 and then this is 7. Now, as you can see, all of the ends of my branches are all prime numbers now. What does that mean? It means that I can highlight the numbers at the end, and the numbers at the end, I multiply them to give me my answer. So I can say 56 then is now equal to 2 times 2 times 2 times 7. All right. Now I've done this, I've got my factor tree. We have to draw some sort of diagram. Can anybody tell me what diagram I need to draw? Begins with a V. What type of diagram do I need to draw once I get to this point of the question? Can somebody let me know? Right. Brilliant. You guys are all on the board today. Thank you very much, Zariah, Josh, Jeremy, Gideon. We have to draw a Venn diagram, right? So what we're going to do now is we're going to draw 2 circles. We're going to draw 2 circles. So circle number 1 like that. And then we're going to draw another circle. Let me just do it a little bit. Yeah, that's fine, to be fair. I'm being extra. And I'll do another one into shape. Why not? Like that. And then I'm going to call this 70. I'm going to call this 56. And then we just fill in our Venn diagram, right? So remember, we know that in terms of our prime factorization, 70 is equal to 2 times 5 times 7. And 56 is equal to 2 times 2 times 2 times 7. So how do we fill in our Venn diagram? We always start with the overlap. How many factors do both of these numbers have in common? Well, I can see that they both have a 2 in common, and there's only 1 2 that they both have in common. So a 2 for sure would go inside the middle. Now, are there any other numbers that are in common? Yes. If I look across, I can see a 7 here, right? So I can put a 7 here as well. So these 2 7s are in common, so I'm going to put a 7 here. Yeah? And that's the overlap, isn't it? Yeah, thank you very much, Ryan. Now, there are no other numbers in common, so the other values of the factor will have to go on the outer part of the circle. So this 5 here would go here, and then this 2 and this 2, these 2 2s would go on the outside of 56. So therefore, this is our completed Venn diagram. How many of us got to this point? How many of us got to this point? Put yes if we got here. And for those that didn't get here, does this make sense? Yeah, well done, Ebony. Good stuff. Okay, so I'm here now. I've done my factor tree. I've done my Venn diagram. The question asks me to find the lowest common multiple. Could somebody tell me what I do from here, please? What do I do from here once I've got all of this? Any ideas? What do we need to do?
They multiply 2 and 7 together.
Very close, very close. Thank you very much for the input, Rosalia. What you want to do, when you want to multiply, when you want to find the lowest common multiple, you want to multiply all of the numbers in the Venn diagram. Yeah. So to calculate the LCM, when you've got to this point, you just multiply all of the numbers together. Yeah. So 5 times 2 times 7 times 2 times 2. So what we're going to do is we're going to put this into our calculator. We're going to put this into our calculator and see what it gives us. Yeah. So it's going to be 5 times 2 times 7 times 2 times 2. This is equal to 280. So the lowest common multiple is 280. Yeah. And well done to Zabraya and Aaliyah for giving me the right answer in the chat. And just as another thing, I was actually going to say this as well, which is good. Rosalia mentioned it. There is something that you need to calculate when they do ask you to multiply the numbers inside. Does anybody know what that is? That's the other type of question you can get. What is it called when you have to multiply the numbers inside? Oh, very close, very close. The highest common factor. Highest common factor, guys. Yeah. If they ask you for the HCF, right? It would be the highest common factor. And that is calculated by just multiplying the 2 numbers in the overlap, 2 times 7, which is equal to 14. Yeah. So remember, you get your 2 factor trees, you put it all into the Venn diagram. Now, depending on what they ask you, if they ask you for the LCM, you multiply all the numbers together. If they ask you for the highest common factor, you multiply the 2 numbers inside. No, sorry, not the 2 numbers, the numbers inside the overlap. In this case, there were only 2 numbers here. Yeah. Does that make sense, guys? Is that all clear? we'll make sure we're all okay with that. And I'm just going to just check the chat just to see if there's anybody that still can't hear me or disconnected. Uh, I think I just saw somebody. Uh, so I'm just looking in the chat. Okay. Hi, Ivano. Can you hear me now? It says that you're muted, so I think you can hear me now. So just drop me a message. Oh, you can finally hear. We thank God. So let me just go through, let me just run through everything just before we continue. So we've done two questions so far. The first question was circle the expression that means half the value of X. So obviously what I said is you just use normal numbers to get an idea of the question. If X was 10 and we halved it, it would be 5 because that's 10 divided by 2. If X was 100, it would be 100 divided by 2, which is 50. So we now extend that to algebra. So it's X over 2 for the first one. And then this was the second question we've done today. Find an LCM of 70 and 56. So as I said before, I think you probably caught the end of this. But yeah, we get two factor trees. You put your factors into a Venn diagram. Now, when they ask you for the LCM, you multiply all of the numbers inside. When they ask you for the lowest common, when they ask you for the highest common factor, you multiply the two numbers in the overlap. Yeah. Yeah, this is for paper two. So what I'm doing today, I'm going over calculator questions. Yeah. Sometimes I know, to be fair, LCM questions and HF they do come on the non-calculator paper, but I've looked as well, and they also come on the calculator paper too. So I thought it would be good to try. Anyways, let's have a go at this one. The next one is 4 marks, right? So we're gonna have a go at this one. I'll give you a chance to try it, and then we'll go through it together. So here's the question. It's 4 marks. Have a go at it. See how you go on. See you later, Josh. See you later, Josh. Thank you for joining. So have a go at that. See how you go on. We'll go through it together very shortly. How are we all getting on with this question, guys? These are the types of questions that come up on a calculator exam. Put a 0 if you're very stuck, you don't know what to do. This is very confusing. And put a 10 if this is super easy. I wish the whole paper was this question because I'd get 100%. How are we all feeling? Put a 0 if you're very stuck, very confused. Put a 10 if this is super easy. I can see 10s, I can see 6s, I can see 10s, good stuff. 6s, good stuff. I can see an 8, good stuff. I'll give you about 2 minutes more. We'll go through it together. I've got a couple of answers, which is good to see. So I'll probably give you guys about a minute more. Yeah. I've got a couple of answers, which is very good to see. So based on the amount of answers I've got, I feel like it's been enough time. I'm going to go for it very, very shortly now. So let's have a look. So let's see what we've got here. Now, it says there are 400 counters in a box. The counters are red or yellow or green. Now, we've got a bit of information here about two of the colors, right? 3/8 of the counters are red, 82 of the counters are yellow. What percentage of the counters are green? Yeah. So for me, what I like to do with these types of questions, I like to take it bit by bit. Yeah. We've got 400 counters in total. We've got 400 as the total. 400 is equal to total. Now it says 3/8 of the counters are red, right? 3/8 of what? The counters. How many counters are there? There are 400. So do we agree, guys, that this means, I'll write this as step number one. Do we agree that step number one means 3/8 of counters, which is 400? Yeah? Are we in agreement, guys? Yeah? Good stuff. Good stuff. Now, let's calculate this. Let's see. Okay, well, what does of mean when we're dealing with these types of questions? Well, of is just times. So it's 3/8 times 400. Now we could use our calculator, so we can directly calculate how many red counters we have. So let's do that. Let me get my calculator. So you should see my calculator in a second. So we have 3/8 multiplied by 400. Yeah? This is equal to 150. So for sure, there must be 150 red counters. How many of us got to this part? Now, step two, it says 82 of the counters are yellow. Now, remember, there are only three types of counters. There are red, yellow, or green. So now that we actually have the values of two of the counters, we can calculate the other color, green, by adding these together and minusing it, right? So remember, from step two, they've told us, we didn't have to calculate this time, they've told us that there are 82 yellow counters. 82 is equal to yellow. So what we're going to do to calculate the green counters, the green counters will equal to the total, which is 400, right? Minus the amount of red counters that there are, 150, minus the amount of yellow counters there are, 82. So let's calculate that and see what that gives us. We've got 400 minus 150 minus 82, right? And this equals 168, yeah? So therefore, there must be 168 green counters. Now, the question didn't ask us for the amount of green counters. They asked us for the percentage, didn't they? Yeah? What percentage of counters are green? Well, the percentage of counters are green will be the amount of green counters around 168 divided by the total green counter, by the total counter, sorry, 400. We multiply this by 100, don't we? Yeah? So therefore, I'm going to put this all into my calculator. 168 divided by 400. And we multiply this by 100. This is equal to 42. So it's 42%. Well done to Zariah, Jeremy, Rosalia, Aaliyah for giving me the correct answer. For anybody that didn't get this, that maybe got a bit close, does this make sense? Does anybody have any questions? I'm going to just zoom out so we can see all of the working. Is this clear? Just zoom out so we can see all of the working. And good evening to anybody that joined a few moments ago. Apologies, I'm not sure. I sent the email out to everybody, but maybe some people didn't get it. But good to see that you're here. So we're just going over random past paper questions. And yeah, if you have any questions, just let me know. Sorry, did I say good evening? Sorry. If I said good evening, it's because I do group classes, as majority of you guys know, I do classes in the evenings all the time. So I think I said good evening. Thank you, Zariah, for correcting me. But yeah, I hope that's all clear. And yeah, so let's go to the next one. Good evening. Sorry, guys. Okay, cool. So let's do this one here. This is a standard form question, can come up on a calculator paper. It's 4 marks in total. So I'll give you about 4 minutes. But if you're really good at standard form, it should take you about 2 or 3. Yeah, so have a go at that, see how you get on, and we'll go through it together. How do we find standard form as a question, guys? How do we find this as a topic? Put a 0 if you find these very confusing, very difficult, don't know what to do, and put a 10 if these are super, super easy. What do you guys think? I want you guys to give me a number between 0 and 10. See a 5, you can see an 8. See a 6. Good stuff, good stuff. We'll go through it very, very shortly. So I'll give you guys about a minute more and we'll go through it all together. Okay, last few seconds. We'll go through it together. Okay. So let's do question part A together. It says write the number 0.00007547 in standard form. Now this question, super, super easy. All you've got to do is this. So whenever I'm doing these questions, I look at this here. I look at this number at the end, the numbers without the 0, 7547. Now I'm going to write this number in standard form. And remember, we know that the number has to be between 1 and 10. So you always put the decimal place between the first and the second digit. 7.547. Now, you're going to times, I remember in standard form, you times by 10, and then you put a power here. Now, you do this. How many zeros do I have here? I have 1, 2, 3, 4, 5, right? So I put 10 to the power of 5. Is that correct, guys? Is that one mark in the bag, or is there something I'm missing? What do we think? Is this correct? What do we think about this one? Is it 10 to the power of 5? No. Thank you very much, Ebony. It's not. It's -5. Why? Because it's 0.00000. That negative means the number is very, very small. Yeah? Yeah, exactly. Thank you very much, Ivano. Fantastic. It is. Yeah. I was just testing you guys. Well done. Well done. Yeah? So just remember, if you have this here, you count how many zeros there are. There are 5 zeros. So you put -5 and with a 10 there, and then you just put that number at the front. Super easy question. How many of us got this correct? How many of us got this correct? Let me know in the chat. I can see Rosalia did, Zariah did, Aaliyah did. Well done. Good stuff. Good stuff, Carter. Good stuff, Shay. Good stuff, Che. Cool. Now, let's do part B. Write 3.42 times 10 to the 4 as an ordinary number. This is a calculator paper. We just put it in our calculator. No, we don't need to do anything. 3.42 times 10 to the 4 times 10 to the 4. 34,200. That's it. 34,200. And now this one, work out 2.3 times 10 to the 4 times 6.7 times 10 to the 3, all divided by 5 times 10 to the minus 8. So with this one, again, this is an easy question, but just make sure you write it exactly how it's given to you in your calculator and you'll get the marks. Yeah, so let's make sure. Let me get my calculator up again. And yeah, so let's put it in everything. We've got 2.3 times 10 to the 4 times 10 to the 4 times 6.7 times 10 to the 3 divided by, so let's double check, 2.3 times 10 to the 4 times 6.7 times 10 to the 3. Perfect. And we're going to do 5 times 10 to the minus 8. 10 to the minus 8. This gives us this. Perfect. 3.082 times 10 to the power 15. 3.082 times 10 to the power 15. Well done to Zariah, Aliyah, I think Rosalia as well. And anybody I missed out, apologies. There's quite a lot of you today. Well done, guys, for getting this all correct. Yeah? Is that clear? Anybody have any questions? Okay, cool. So that one's okay. So let's continue to another question. We're going to do this one here. So this is 5 marks. It looks like a big one. I'll give you about 5 minutes to try it. Have a go at it, see how you get on, and we'll go through it together. Yeah? So it's 5 marks, I'll give you about 5 minutes. So about 10:34, 10:35, we'll go through it together. How do we find these types of questions, guys? Angles and parallel lines. We know that it always comes up. How do we find it? Put a 0 if you don't like these questions. Hate when they come up, hate when you see them, and put a 10 if these questions are super, super easy. These questions are so easy, they're not a problem whatsoever. I want everybody to give me a number between 0 and 10. I can see 10s, I can see 6s, I can see 7s, I can see 5s, 2s. Okay. So for those of us that are a bit stuck on these ones, I find it a little bit more challenging, right? Always remember there are many, many rules that you need to know. Yeah. What I'll do before we go through it together, I'll get all of the rules up and then we'll check. Evening to anybody that just joined. I keep saying good evening, I'm so sorry. Good morning to anybody that just joined a few moments ago. We're just going over random past paper questions today. We've got paper 2 coming up in a few days. So we're just going over random past paper questions. So we've done a couple so far. What I'll do at the end of the lesson, I'll send a link out with the online notes so you can access the work that we've done. And I'm also going to put this on YouTube as well. So don't worry. I'll give you guys about a minute more. We'll go through it together. Last 30 seconds. Okay. So we've got a 5 marker here. I know a couple of us have given me an answer already. If you have an answer to the question, please put it in the chat and then we'll check. So let me put this here. Let me put this a bit lower here. So got this here. Now it says in the diagram, PQR is an isosceles triangle with PQ equal to PR. APR and CQD are parallel lines. BPQ is a straight line. Okay, BPQ is a straight line. Fine. Work out the size of angle CQR. Give a reason for each side that we're working. So for me, what I always like to do with these types of questions is I like to identify what actual angle it is that they are referring to. Yeah. So the angle CQR, right? Where's my pen? There it is. The angle CQR, right, would be this one, wouldn't it? CQR, this entire angle here, right? So for me, that tells me, okay, well, I've got 2 parts to the question. I need to figure out what this angle is here somehow. I need to figure out what this angle is here somehow. Add them together, and that will be the angle CQR, wouldn't it? Right? Now, before we get into this, what I'm going to do is I'm going to get you the rules for all of your parallel lines. Yeah? All of your angles and parallel lines. So let me just go to it. Let me foundation. When did I do parallel lines? 19th of September. Okay. Let me get on without the annotations. All right. So looking at this here, I'm going to copy this and put this in our lesson today. Where is it? GCSE Maths webinar here today. Let me just close everything just so I'm not confused. All right. So we're looking at 1st of June 2023. Perfect. All right. So now I want everybody to look at these, have a look at these, and tell me how well you know all of these off by heart. So I'm going to zoom in a bit, don't worry. I'm going to zoom in a bit, right? So looking at all of these guys, having a brief look over these, how well do we know these? Put a 0 if I don't know these at all, and put a 10 if I know these perfectly well. I can recite every single one of them, no problems. I want everybody, every single one of us, to put a number in the chat. 0 if you have no clue about these rules, and put a 10 if you're perfectly fine with these. You know these particularly well. What can I see so far? I can see a 10. I can see 2 10s good. I can see a 9. I can see an 8. I can see a 4. I can see an 8. I can see a 7. I can see an 8. I can see loads of 8s. So on average, we know these rules pretty well. Yeah, for those of us that may be a little bit lower in terms of the number, what you need to do with these types of questions is you need to know these very, very well, because depending on the type of question they give you determines which rules you're going to apply. Yeah. So remember, they don't give this to you in the exam. You need to know these off by heart. Yeah. So let's just have a brief look over them again. I can see we've got 10s, 8s, and 9s for those of us, for the majority of us. So let's apply these to the question. Yeah. I know them will just mix up their names. That's fine. That's fine. If you know them and you mix up their names, that's not a problem, because they don't ask you for the names. Actually, no, they do. They do. They do. They ask you to give a reason, to be fair. Yeah, actually, don't. I didn't say that. Yeah, because they will say, give a reason. So you want to give the correct rule. Yeah. So for example, if it's alternate angles and you put corresponding angles, you'd get it wrong. Yeah. So yeah, make sure you know your names. Yeah. As well as the rules. Obviously, knowing the rules is the first step, but make sure you know the names as well, because they do ask you that. Yeah. Cool. Anyways, let's apply this. So what I'm doing in an exam, I'm looking at this question. I'm saying, okay, well, what rules can I see here? I've got 2 angles that I need to find. And for me personally, I have an isosceles triangle. What does it mean when a triangle is isosceles? What does that mean about the angles at the bottom? Can somebody remind me? What does it mean if a triangle is isosceles? Exactly. Thank you very much, Zaraya, Rosalia. They are the same. So this angle here is also the same as the green one. So I'm going to highlight this as green too. Yeah. Now, for me, the first thing that is glaring for me to see when I'm looking at this hair, right, is I've got this hair, right? Now, there is a rule that connects both of these together. Can somebody remind me of the rule? It was just there when I showed you, but does anybody remember it off by heart? Exactly. Remember, not opposite, vertically opposite. Thank you very much, Zaraya Rosalia. It's vertically opposite. Yeah. So vertically opposite. And that's the rule. What does it tell you about the angles though? Are they the same? Are they different? Is one more than the other? What does it mean? We've got the rule. What does it actually mean though? Exactly. Thank you very much, guys. They're the same. So because these angles are vertically opposite each other, I can write this as a 56-degree angle. Yeah. Now, what else do we have though? Well, we've got a triangle. We know that two angles are the same in this triangle because it's isosceles. That means I can calculate the green angles, right? Because we know that angles in a triangle add up to. What do triangles and what do angles in a triangle add up to, guys? 360, 720, 180. Thank you very much, Zaraya. Angles in a triangle add up to 180. Thank you very much, Gideon, Ebony. They add up to 180, right? So what does that mean? It means, well, I can calculate these angles here. Well, it would be 180, right? Minus the 56-degree angle. Let's do this, huh? Let me get my calculator. 180 minus 56. This is equal to 124, right? Now, because these angles are the same, it means that we just have to half this value of 124, and that will give us each one. That would be 62 degrees, wouldn't it? Right? Half of 124 is 62. So this is 62 here. This is 62 here. Okay. Now we're nearly there. Remember, we need to figure out the entire angle CQR, which is comprised of the yellow angle and the green angle. So we've got the green angle. Now we need to figure out what the yellow angle is. Now for me, another thing that I can see here is that, remember, using our parallel lines, right? Using our rules here, what I can see is this. I've got an upside down type of F shape going on here. I've got an F going on here. Can we see? If you tilt your head like that, you've got an F. What rule does that represent, do we think? What rule? Let's have a look at our diagrams again. Where can we see an F anywhere? Exactly. Thank you very much, Rosalia. It's corresponding angles. Can we see we've got an F here? Look at this one in the bottom corner. We can often spot corresponding angles by drawing an F shape. F right there. And these angles are the same. Can you see? We've got an F shape here. It's just upside down, isn't it? So that means that this angle here is yellow too. So this is also 56. So you're going to say this is 56. And then you're going to say corresponding angles. Corresponding angles. Yeah? So now we know the two angles. So therefore, the angle CQR will just equal 56 plus 62 degrees. Now 50 plus 60 is 110. 6 plus 2 is 8. This is 118 degrees. And well done to Aliyah, Zoraya, Che, and anybody else that may have missed out. Well done, guys. The answer is 118. Does that make sense, guys? How many of us got this correct? Well done, Jeremy. Good stuff. Well done, Carter. Good stuff. For anybody that didn't get this correct, is this clear? Remember, the key to these types of questions, what you want to do is you want to know these rules very well. Yeah. So you know how we're looking at them and we're saying, okay, this rule is that one, this rule is that one. You're looking at it in your head. In your head, you need to know these off by heart, right? And then apply it to the question. Yeah. Cool. So let's continue and see how we get on. Yeah, angles in a straight line. That's a good question. Angles in a straight line do add up to 180. But so do angles in a triangle as well. Yeah, so with our working out, we didn't need to use that rule. Yeah, but that's not incorrect. Angles on a straight line do add up to 180 as well. But with our working out, we didn't have to use that anywhere. We just used vertically opposite angles, isosceles triangles, and corresponding angles. Yeah, that's the rules that we use. So yeah, there's always many ways to do these types of questions. This is just one way. Yeah. Cool, cool, cool. So let's continue. So we've done that one. Let's have a go at this one. This is another 5 marker. Let's see how we get on with this one. So this one here is 5 marks. I'll give you about 5 minutes to try it. I'll give you a chance to draw the diagram too, and we'll see how we get on with it. So we've got a trapezium here, and apparently we need to work out the size of angle CDA. They've given us a lot of stuff here. They've given us some distances, right? We need to work out the size of angle CDA. Now, how are we feeling about this question, guys? What are our thoughts? Put a 0 if you have no clue where to start, no idea what's going on, and put a 10 if this is I know what to do. There's a lot going on here, but I know the steps. I know exactly what to do, and I'm pretty sure I'm going to get the correct answer. What do we think, guys? Put a 0 if you don't know what to do. Put a 10 if you're completely in control, just so I have an idea as to how everybody's getting on. Okay, okay. Okay. Well, I can see a couple zeros. So for those of us that are a bit stuck on this, let's read it together. And I'll try and give you a pointer starter, right? So the first thing that I would say is that they asked to work out the angle CDA. Now, where is the angle CDA? That is the angle here, isn't it? So somehow I need to work out what this angle is. I call it X. This is the question. I need to work out what this angle is here. Now, how do I do that though? Well, I've got a vertical line here, right? Which is dashed. And I can see that I have a right angle triangle, right? So there's triangles going on here and there's angles, right? Now, I could also do another dashed line here, like this. And can somebody tell me what this distance would be? This dashed line. Can somebody tell me what this distance would be, please? Right. Thank you very much. So, right, it'll be 6 because it's just exactly the same as this one, isn't it? Because it's just the same distance. This would be a 6. And this would be a right angle triangle, right? So for me, looking at this question here, I've got a right angle triangle on the right hand side with a missing angle. What topic is this reminding you of? What are we thinking? We have a right angle triangle. They've given us one side and we need an angle. Exactly. Thank you very much, Ivano. It's trig for sure. It's trig for sure, definitely. So what you want to do is, okay, it's trigonometry. How do we use trigonometry? Well, we need a couple of other sides, right? Well, if I knew this side somehow, right, I'd be able to use trigonometry, SOHCAHTOA, to calculate the angle. But we don't know that side. So the question is, well, how can we calculate that side? Yeah. Well, what do we know? The entire distance going along is 24. I can see that I've got this here, right? This is the same as this one. This is 10. Yeah. Now, this one is also part of that line, but it's not given to us, right? If we could calculate that green distance there, we could add it onto 10 and then subtract it from the entire thing, 24, and that will give us this blue distance here, and then we can use SOHCAHTOA, right? So try and see if you can figure out what that green distance is somehow, some way, and take it from there. Does that make sense, guys, for anybody that was a bit stuck and that put 0? Trying to make sure we're all okay with that. And we're going to go through it in about 2 minutes. And where can I find the different types of angles fact sheet that you use? Yeah, so what I'll do before the lesson finishes, I will put my link for the online notes, right? So for those of us that are not in my group classes, I give a link out where you can access these notes whenever you want. So what I'll do after the lesson ends, I'm going to put the link. So if there's any fact sheets that you want, then it will be there. Yeah, but yeah, I'll give you guys about 2 minutes more and we'll go through it together. Give you guys about a minute more. Okay. Okay. It's been about 5 minutes. Let's run through this together. If anybody's got an answer, please put it in the chat. But yeah, let's read it. Let me rub all of these out so we can do it again. Let's rub all of these out. Okay. So ABCD is a trapezium. We've got a couple of distances here. And we just need to work out the angle CDA. So as I said before, first thing that I will do is I'll say, what is the angle that I'm looking for? Angle CDA. It's this one here at D. Yeah, I'll call it X. And then, well, for me, that angle there and the fact that I have this dashed line, which is a right angle triangle here, this tells me that, well, this must be some sort of trig question for sure. Now, I'm not sure where I'm going with it, but I'm going to say to myself, this is looking maybe like a trig question. A bit hard, but there's probably trig involved, right? Now, looking at this, I've got this here, X here. I know that the only way I can calculate angles when I'm dealing with maths in paper 2 and paper 3 is if they give me trigonometry, right? And you can make right angle triangles in trapeziums because, as I said before, if I just draw a vertical line like this, right? This will be a right angle for sure. And this is 6, isn't it? Because it's just the same as that side there. Now I have this right angle triangle here. I'm gonna draw it out like this. Okay. This here is a right angle, that's X. This side is 6, yeah? Now this is C, and I'm gonna call this point, it's not given to us, I'll just call it, I don't know, M. And this is D, yeah? Now, to answer the question, we need a little bit more information about this right angle triangle. We need another distance for us to be able to calculate the angle using SOHCAHTOA. But we know that the entire length is 24. As I said before, this distance here is just 10, right? And then this distance in green, right? This distance in green is unknown to us, but we can see it's the base of one right angled triangle. So what I'm going to do is I'm going to say, well, I've got a right angled triangle here, like that. This is 7.5, right? This is 6. Is there any way of me calculating this missing side? Does anybody know any rules or theorems that we know that we can use to calculate that missing side in green? Because if we can calculate that, we've got it. You see cosine, right? Not quite close. Think about it. Remember, you use trig, right? When they maybe ask you to find the missing angle or they give you an angle. But remember, if you have a right angle triangle and you've got 2 sides out of 3, you can just use Pythagoras' theorem, right? You can just use Pythagoras' theorem. So remember how does Pythagoras' theorem work? If I have a right angle triangle like this, I'll do it the same way around. Yeah, this is A, this is B, and this is C. Well, the Pythagoras theorem states that A squared plus B squared is equal to C squared, isn't it? So in our case, we can see that 7.5 is C. We can call this B, and this is A. So therefore, we've got A squared plus, plugging everything in, 6 squared is equal to 7.5 squared, right? And then now what you can do is just move the 6 squared over. So we get A squared is equal to 7.5 squared minus 6 squared. And then we're going to put this into our calculator and see what it gives us for A squared. Yeah? Get my calculator out. This gives me 7.5 squared minus 6 squared. This gives me 81 divided by 4 or 20.25. So A squared is equal to 20.25. And then how do we get A from here, guys? What do I need to do to get A? It's A squared at the moment. What do I do to get A? Can somebody tell me? Exactly. Thank you very much, Zariah. Ivano, we square root, don't we? We're going to square root. So it's going to be 20, the square root of 20.25. Whoops. Sorry, I think my thing just glitched. Let me get it again. Okay, perfect. Let me go back there. Okay, cool. So going back there, yeah, perfect. Square root of 20.25. We get this here. This gives us this here. So I'll put this into my calculator. Square root of 20.25, square root of answer is 9/2, 4.5. Yeah? This is 4.5 here. What is cosine? Sorry to ask. Cosine is just one of the trigonometric expressions for SOHCAHTOA. I'm gonna go for it, so don't worry. For anybody that's asking about cosines, don't worry. So yeah, what is that? 4.5. So therefore, this here is 4.5, right? This is 4.5. That was 10. So this distance here in blue, which I need to calculate to answer the question, right? Well, this will just be equal to. This will just be equal to the entire distance of the entire line at the bottom, 24, and then I would minus 10 and minus 4.5. And then this will give me 24 minus 10 minus 4.5 minus 4.5. This is equal to 9.5, isn't it? Yeah? So therefore, this is 9.5. Does this make sense, guys? Anybody confused or stuck on this one just before we continue? This all clear? Just want to make sure all okay just before we continue. Okay, cool. So I'm not seeing any messages, so I'm assuming this is all okay. Now remember, the question was asked us to work out the size of angle CDA. So this was a long-winded type of question. We had to use Pythagoras' theorem. We're going to use trigonometry now. Now, how do we do this from here? Well, we have to use SOHCAHTOA, right? So we've got this triangle here, SOHCAHTOA. Now remember, when you're dealing with SOHCAHTOA, there's always the first thing that you want to do. You want to label your right angle triangle, right? Remember, you've got three different types of sides. You've got the opposite, the adjacent, and the hypotenuse. Hold on, let me just move this back here. I need to get the triangle. Okay, let me move this triangle here. Oh, I know what to do. I'll just move this here, and then I'll just write this out again, 24. Because I carried this one, didn't I? Perfect. All right. Now, there are three types of sides, yeah? There is the opposite side, there is the adjacent side, and there's the hypotenuse. Now, I'm going to label this number 1, I'm going to label this number 2, and I'm going to label this number 3. Can somebody tell me what the side number 2 is out of the opposite, adjacent, and hypotenuse? What is the side number 2? Can somebody tell me? Thank you very much, Ivana. Zaraya, it's the opposite. How do we know, though? And thank you very much, Che. How do we know? Well, you get an angle, the angle that you have here, you draw a line opposite it. The side that it takes you to is always the opposite side. So this here is for sure the opposite side here. Yeah? So I'm going to label this as opposite. That's fine. Now, how about the side number 3? Can somebody tell me what the side number 3 is? Yes, thank you very much, Zaraya. It's the adjacent, isn't it? Yeah? How do we know? The way I always remember it is it's always the side in between the right angle and the angle in question. So this is the adjacent side, yeah? So I'm going to wrap this, I'm going to call this the adjacent. The adjacent, huh? And then the last side is the hypotenuse, which is the longest side, it's the diagonal side, and it's the side opposite the right angle. This is the hypotenuse here, yeah? Now, once you've correctly labeled your right angle triangle, you ask yourself 2 questions. What side, no, 1 question, but 2 sides. It's depending on what type of trig question they've given you. What side have they given us? Well, I can see that we've got a 6 here, and this represents the opposite. Now, what other side have they given us? They've given us 9.5, right? And this is representing the adjacent. So these are the 2 sides given to us. I remember we need to figure out what the angle X is, yeah? Angle X. So now you ask yourself, okay, I've got this piece of information here. Which out of the 3 SOHCAHTOA are we using, guys? Is it SO? Is it CA? Is it TOA? Can you guys tell me in the chat, please? Which one is it? Is it SO, CA, or TOA? I can see one answer already. Right. The correct answer is TOA. For anybody that maybe got a bit different, ask yourself this question. Well, we've got the opposite side. That's an O. This is an O. So you look at your acronym and say, well, which ones have O? This one does, and so does this one. So it can either be out of SO or TOA. Now, what's the other side? The other side is an A, adjacent, right? It's an adjacent. Well, which other one has an A in it? It's the TOA. So it has to be TOA we're using for sure. So now you say it's definitely TOA, right? And then now, what does TOA actually mean when we write it out? TOA means the tan of the angle is equal to the opposite divided by the adjacent. Now, the angle in this case is x. That's what we're trying to find. The opposite is 6, and the adjacent is 9.5. So we get here, yeah? So now we get here. Can somebody tell me what I do here, please? We need to get x on its own. There's an issue. We've got this tan. How do I get rid of this tan? What do I do to get rid of that tan? Can somebody tell me? Right. Thank you very much, Rosalia. We need to do the shift button on our calculator, don't we? Oh, very careful. I can see somebody's put in the chat, divide by tan. Not quite. To see why you'd say that. But tan is not a number. The same way if it was, for example, if it was, I don't know, 4x is equal to 6 divided by 9.5. 4 is a number. 4 is times in x, so we just divide by 4, right? Tan is not a number. Tan x does not equal tan times x. This is not correct, yeah? Tan is not a number. The way we get rid of tan is we use a special function on our calculator called shift, right? What you're going to do is you're going to take it's called the tan inverse, right? And you calculate that by doing the shift button on your calculator. You're going to take the tan inverse of both sides. So x will equal the tan inverse of 6 divided by 9.5, right? Now you put this into your calculator. So my calculator is here. Calculator is here. Tan inverse is 6 divided by 9.5. And this gives me 32.3 degrees. And did it want it to one decimal place? I think it did. Yeah, 32.3 degrees. So x is equal to 32.3 degrees. I wanted to Rosalia for giving me the correct answer in the chat. Anybody else get this correct? Anybody else get this correct? I'm going to zoom out so we can see all of the working. Yeah, good stuff. Well done, Shay. Fantastic. So before I let you guys go, how are we feeling? Found that beneficial? How are you guys feeling for your exam next week, paper 2? You're welcome. You're very welcome. You guys feeling confident? Good? Good stuff. Good stuff. Okay. Now, just before I let you guys go, what I'm going to do is I'm going to send a link out with the link to these online notes so you can access all of the work. Yeah, that's good to hear that you're feeling more confident, Ivana. Let me just get it up. I should have done this before the class, but it doesn't matter. All right. Yeah, let me get up now. So what I'm going to do is I'm going to get a link up. Hold on, let me see if I can find it. Yeah, perfect. Okay. So you should see a link in the chat in about 3, 4, 2, 1. Okay. Yeah, I've sent a link in the chat, right? It's onedrive.live.com, blah, blah, blah. If you click on that link, it should take you to your browser. What I'm going to do is I'm going to go in my browser and show you what it should look like. Yeah, just give me a sec. Okay. So let me share my screen. So if you click on your browser, if you click that link, it should look something like this, right? So this is the notes that we make online. So if you want to access what we've done today, you just go to GCSE Maths webinar. You're going to go to 1st of June 2023, and then you're going to go to foundation exam questions. And can you see this is everything that we've done today? Yeah. So you can access all of the work we've done. There was a couple of questions that I didn't get to run through in the hour. You could go on June Solutions, go on Foundation, and check these answers here. As well as that, I run classes every week, and I have them in different classes. So for Foundation, I have classes on different days, Mondays and Thursdays. What you can do, there's loads of topics here. You can click on any of these different topics. These are the topics I teach every week. You can click on them and just go on any different type of topics. For example, trigonometry I did on the 30th of January with my students. There's a couple of questions here with lots of working out. You can access this there. And somebody did ask about the parallel lines sheet. So what you can do, so Thursdays is not, go up to September, go on either Monday or Tuesday, go to the 19th of September parallel lines, and you can access that that formula sheet that I was referring to, this one here, yeah? Does that make sense, guys? Has everybody got that? Did anybody click on the link? Is that clear? Yeah? Cool. The link works? Okay, cool, cool. And lastly, for those of you that don't know, I'm also on Instagram, TikTok, and YouTube. So if you want to follow me, I'm going to be uploading a lot more videos on TikTok, especially because TikTok is great. You put a video up, loads of people comment and like and share. So I'm going to start doing more of that. If you want to follow me on TikTok, you can do. I'm on Instagram as well, and I'm on YouTube. I'm going to upload this lesson. I'm going to upload this lesson on my YouTube channel, probably do it tomorrow because I've got a very busy day. So if anybody did join a bit late, you'll be able to access the video on YouTube when I upload it. But yeah, we'll leave it there, guys. Good luck for your exam on Tuesday for those of you that have it. Have a fantastic rest of your half term. I hope you found this beneficial, and I'm sure I'll see some of you guys again soon. Take care.